Hello! In this quick take video, I will show you how to use the latest features of the Vivado Hardware Manager for Memory Interface Generator MIG designs. With a new MIG feature in the Vivado Hardware Manager, you can quickly verify the calibration and read window margin in your memory interface design. This will help you bring up, understand, and debug your memory interface design faster than before. This tutorial uses the VCU 107 board that features a Vertex UltraScale VU095 FPGA with a 2400 megabit per second DDR4 80-bit wide memory interface. The DDR4 design has been generated using the MIG IP in the Vivado IP offering. For this tutorial, I'm going to walk you through 4 steps. First, I'll download the bitstream through the JTAG USB cable from my laptop running the Vivado Hardware Manager 2014.4 release. This will also start the calibration and the test design of the DDR4 memory interface to check the full functionality of the controller and interface. Second, I'll look at the Vivado Hardware Manager MIG GUI to observe the calibration status. Calibration is the stage of the design that centers the clock to the data valid window for proper operation of the memory controller and interface. Third, I'll look at the calibration read margin of the DDR4 interface displayed in the MIG Hardware Manager GUI for both rising and falling edges of the clock or DQS. Fourth, I'll look at the ILA, the In-Circuit Logic Analyzer core, that is also part of the Vivado Hardware Manager to verify that the write and read operations are error-free. Let's now go through the first step. We'll start the bitstream download. Let's take a look now at the Vivado Hardware Manager. As programming completes, the MIG GUI will start displaying information extracted after completion of the memory interface calibration. One of the panels displays the type of memory core or design that has been implemented. In this case, it's DDR4, single rank, and 10 byte wide or 80 bits, or as displayed here in hex. As the test completes calibration, the MIG Hardware Manager GUI will immediately indicate the calibration results. As you can see here in this panel, we have the calibration results. The green pass message indicates the successful calibration and various stages that have passed, or may have been skipped for this version of the design. The second panel displays the actual read window margin in number of taps. The display is for both rising and falling edges of the DQS with respect to the data valid edges. This is displayed for each nibble of each byte. In this case, we have 10 bytes and therefore 20 nibbles. There are 3 numbers in this table: left margin, the position of the center point, and the right margin, all shown in number of taps. You'll observe some variations in the margin across nibbles and bytes, but data shows consistency in terms of centering the DQS to the data valid window, as well as substantial margin for both setup and hold time. You can change the table display from rising to falling edge and observe similar results. Additionally, for a more graphical display, we have this chart option as well. Let's take a look now with the ILA core at the captured data to understand if the writing and reading of the data is error-free. As you can see here for the captured data, we do not see any errors. The read data and the write data are the same. You can also see here the read data valid signal turn high during valid read data periods. When we look at the data itself, you can see the PRBS pattern being used to stress the channel. Running difficult test patterns is key to ensuring a robust DDR4 interface. You have seen Vertex UltraScale FPGA, DDR4 controller and interface running at the 2400 megabit per second data rate with substantial margin. Having this type of calibration margin ensures that voltage, process, and temperature variations are accounted for in your design. Vertex and Kintex UltraScale devices are shipping now. Use the latest release of the Vivado design suite with the Hardware Manager MIG feature and Memory Interface Generator to customize your memory interface and accelerate your design schedule. For more information, please visit xilinx.com/memory.